Hi, and welcome to episode number 95 of the weekly Google Cloud Platform podcast. I am Francesc and Mark, and I'm here with my colleague Mark Mandel. Hey Mark, how are you doing?
I'm so much more awake than you are.
I know. This is my second Monday this week. And it is hard. I just flew back from Sydney, landed a couple hours ago. So yes, indeed, I am very, very, very jet lagged.
So podcast listeners, say thank you to Francesc, send him tweets, send him pictures of puppies. He came directly from the airport just so we could record an episode.
I might not read them because I might be sleeping by the time you send those pictures. But yeah, I think it's going to be worth it because we have a lot of really cool things of the week. There's some of the cool things of the week today that I'm very, very excited about.
Yep.
And then for the main content, we're going to have a friend of mine, Quinn Slack. He's the CEO and co-founder of Sourcegraph. And Sourcegraph is a company that they use Go, basically, and they allow you to do kind of like advanced navigation of source code, but directly in your browser. And it is really cool. It works not only for Go, but for many languages. And the infrastructure behind also runs on Google Cloud. So he's going to come and explain a little bit about all of the cool things they do and how they do it and why they do it that way.
Yeah. Finally, after that, we will have our question of the week talking about basically how do I remove personally identifiable information? Say I have a stream of data coming from outside, so user-generated content. What can I do to get rid of that in an automated fashion?
Yeah, it is an interesting question with a very, very interesting answer. It's an API, but that will be later.
Yep.
So we're going to go directly with the cool things of the week then. The first one, and I am very, very excited about this one because I've been waiting for it for quite a while, it is that we finally have managed SSL for Google App Engine. And what that means is that now you do not need to create or even manage your HTTPS certificates for App Engine when you're using custom domains. Until right now, if you got an address that was something.appspot.com, and that one came with HTTPS automatically. But if you were trying to do something else like GCPPodcast.com, for instance, you needed to manage that. Now you don't need to do that anymore. Everything is automated and everyone is happy.
It's fantastic.
Oh, yeah. Also, oh, wow, that was really bad. It's another cool thing of the week. Today is Talk Like a Pirate Day.
I had to slip that in there.
This is a very bad joke. What's the favorite programming language of pirates?
Arr.
Exactly.
That is a terrible joke.
I know,
yes.
But it's totally on topic. Anyway, we have a second cool thing of the week that comes from our friends at Spotify.
Yeah, so Spotify has been working directly with GCP security team, releasing a product called Forsetti. Forsetti is really cool. It's an open source tool that enables you to basically do several things over your Google Cloud Platform project. Basically, if you think about it in terms of you're like, I'm going to deploy a bunch of stuff onto Google Cloud Platform, but I want to ensure that I have visibility into exactly what's happening, but then also be able to scan and enforce certain security rules about what I want to have happen. So say, for example, I want to have certain firewall rules across maybe my GCE instances or other things like that. This gives me a way to basically be like, okay, let's look at what's available inside our system. Let's see if it has the rules that are applied to it. And if they're not applied to it, let's make sure that those things are there and make sure that that happens, which is like, security good and stuff.
I really like it because if you have enough instances, these kind of things will happen. Like someone will forget, someone will be doing a little test and open SSH port and then forget about it. And then now you have an attack vector.
Yeah, and even if you're automating it with like Ansible or Chef or Puppet, like maybe something goes wrong, it's just an extra layer there to basically say like, let's just make sure this is always locked down.
It's not even only just warning, but you can actually say, okay, just drop that at a rule, close that port. So perfect. It's very, very nice and completely open source. And I wonder if it's reading Go. It's probably reading Go.
All right, while you're looking that up, I will talk about the last one. There's a Medium article by, I'm going to read the name of the post here, Christopher Grant, or possibly Grant, depending on which country he comes from. Talking about building global Kubernetes in 3 steps on Google Cloud Platform. I particularly like this because I was literally reading this morning about how to set up federated clusters in Kubernetes, and I was pulling my hair out trying to work out what's just the simple steps for how to do this. He's written a Medium post that shows you how to use kubefed, basically just step by step by step. This is how you set up each of the clusters. This is how you create aliases for them, join them up, and then deploy your application across the several clusters that span the globe, which was just super nice to use.
Cool. It's written in Python.
It's written in Python. That's okay.
You're very sad. No, Python is cool too. Anyway, I think it's time to go talk to Quinn about Sourcegraph.
Let's do that.
I am very happy today to welcome to the podcast Quinn Slack. He's the CEO of a company called Sourcegraph that I think I've talked about many times before. And he's here to tell us a little bit about what they do at Sourcegraph and how to use Google Cloud. So hello, Quinn. How are you doing?
Hey, I'm doing great. Thanks for having me on.
Thank you for coming. We're going to be talking a lot about all of the things that you do at Sourcegraph. It's a very interesting company, especially if in the Go community, you're pretty well known. But before we start with that, why don't you tell us a little bit about who you are and what do you do at Sourcegraph?
All right. I am, again, Quinn, and I'm the founder and CEO of Sourcegraph. We build a universal code browser. So if you're a developer and you work with tons and tons of code, reading code, writing code across a lot of different projects, then we have a product that helps you do that. It makes it much easier to read code, to jump around, get all the IDE-like features, whether you're on GitHub, whether you're reading code elsewhere on the web, across all the projects at your company. We have customers with thousands of repositories. We have users who jump around 10, 20, 30 open source repositories, and our product makes that a lot easier for you to read.
So this sounds quite interesting, what it is that you work on, but can you give us a sort of a higher level? How is this different from, say, somebody using just a regular IDE or searching for something in GitHub?
Different in a few ways. So, your IDE is optimized for editing code, and usually in one project. And maybe, 10, 20 years ago, if you're a developer, you could just be working in one project. But these days, you have to use so much open source code or so many other microservices in your company. And the job of a developer has just gotten a lot harder. So we built a product from the ground up that actually understands cross-repository references, linkages. So you can point to any piece of code. You can say, show me everywhere in the open source world or everywhere in my company this thing is being called. You can instantly search across all your repositories, hundreds or thousands of repositories at any version. You don't need to wait for them to be indexed. And so, the tools that we have as developers today, I think they solve the problems we had maybe 10 years ago. But with the explosion of open source, microservices, a lot more things, the job has just gotten a lot harder. And we're building the tools to help developers solve these problems today.
Cool. And that basically is a web application where people can browse the code and everything, but it's also a Chrome extension, right?
Right. So you can get Sourcegraph on the desktop, and that is something that you download, and you can browse all your local code, you can browse remote code, and it's a universal code browser. It makes all the world's code transparently available to you. And inside of that, of course, we have language analyzers, which we call language servers, built on Microsoft's language server protocol, which is the new standard. It was released about a year ago, and already you have servers for most languages, and it's a really cool new standard. We have a lot of people work on language servers internally and a lot of other people at other companies. And then, you can access it on the desktop. You can get it in our Chrome extension on GitHub. So you can be viewing code on GitHub. You can be looking at a pull request, and you put your mouse over any token and you get a hover. You can do find references. You can do go to definition. And you can get it integrated into your own editor. You can get it on the CLI, and you can get it in a web app.
I really like that that Chrome extension is something that I use daily. Whenever I visit GitHub, it's not on. I just feel like GitHub is broken because there's no hover. And then I realize that, it's not part of GitHub. It's actually part of Sourcegraph. It's a very cool tool. Okay, so I think that with this, pretty much people have a pretty good idea of what Sourcegraph does and what is the use case. So let's get into tech. So you have some clients, desktop client, web client, and then you have some servers. What are those servers running?
Good question. The servers are running on Google Cloud.
That's
and
good.
in Kubernetes.
Cool. So is that on GKE, on Google Container Engine?
Yeah, it's on GKE. and we love it. We decided a couple years ago to go all Kubernetes. Can go into a bunch of different reasons, both technical and business reasons.
Yeah, give us one.
Cool. Please do.
So, I am the CEO and founder, but I'm also a dev, and I've been coding for a long time. So, I get to see both reasons why we made this choice. First, let's start out with the technical reasons for making the choice. There's the developer aesthetic reason. You look at Kubernetes and you can tell that it's a deployment system just built by people who've been thinking about this problem for, a decade or more. And Google understands how to build a solution to this problem better than, probably any other company out there. All these little things that, we never would have thought of in our own deployment system and other systems wouldn't have thought of, Kubernetes has addressed, or you can look at their roadmap and they're going to address it. Love that, it's written in Go, that you can read the code, that the CLI is really good. I just feel like it was built for people like us. And, the other technical reason is just it works very well. It was easy to get up and running. It, is well documented. It's a standard tool. And then, of course, we tried it out locally and we wanted to see where we could deploy this. And we saw that Google Cloud, obviously, they have native support for Kubernetes, and you get the feeling that Google Cloud was built with Kubernetes in mind. So that's why we went with it for technical reasons.
Cool. So you sound like you're doing a bit more than, say, like your standard web app or something like that. How are you using Kubernetes? Are you using it in like stateless ways? Are you using it for stateful ways? Are you using deployments, stateful sets? Like how are you using the jobs API? Like how are you using GKE?
We started using it 2 years ago when a lot of these things were not available. And we have a few design decisions we made with our application that make things easier for us. We actually don't need to store a lot of state. So when you go on Sourcegraph and you mouse over something and you see a hover, that's actually being served in real time from a language server process running somewhere in our Kubernetes cluster. So not a lot of state, and the tiny amount of data that we do need to store, it's either one index around cross-repository references or just a cache. So we have our web server front-end process running that has GraphQL and WebSocket APIs. The WebSocket one is for the language server protocol. We have a proxy that the web server will send a language server request to, and then the proxy will figure out, do I need to spin up another Go process or Go server to serve that? And then it'll send it to one of the language server backends, and that will fetch all the repo data from our Git server, also running in the same cluster in Kubernetes. And it'll do all the language analysis, whether that's in Go or Java or TypeScript or Python or C# or whatever. And it'll return, back through the WebSocket and back to the client.
Cool. So I'm wondering, you mentioned that you like Kubernetes partly because it's written in Go. Is Sourcegraph also written in Go?
Oh, yeah. From day one, we wrote Sourcegraph in Go. And initially we chose Go because Sourcegraph is something that understands source code, and Go has amazing libraries, even in the standard library, for understanding its own source code. So it was the natural choice. And we also had been coming, my co-founder and I, from jobs where we were writing other languages, which will not be named. And Go is really nice to start working in. And since then, we've grown to other languages. We still love Go. We still write, all of our stuff in Go, but we have customers and users across a bunch of different other languages. And generally, when we write, the Python language server, we'll do that in Python.
Nice.
So we are polyglot, but we have a special place in our heart for Go.
And I guess that's also one of the benefits of running on Kubernetes is no matter what language you have, you put in a Docker container and then you're ready to go.
Yeah.
Nice.
Yeah, so I want to talk about the business reasons too for Kubernetes.
Oh, go for it.
Yep. Because, I got to think about both. And our product is obviously loved by a lot of people in open source, but it is for companies. It is for companies with a lot of code. And for those companies, it is important to them that their code stays secure. It's important that they run a lot of their core services in their own infrastructure. And it is a really important business decision for us how we deliver our software to these customers. We wanted to make sure that we built it so that it is so easy for a customer to run Sourcegraph internally. And that meant not being tied to any specific vendor's way of deploying or, orchestrating an application. So, if we have customers across all different kinds of clouds, then by using Kubernetes, that is kind of the standard. And it's not the case that every single one of our customers is already using Kubernetes and, we can just slot that in. But it is a very easy sell to them to say, we are built on Kubernetes and, we will ship this to you as a Helm chart. And, luckily our audience is developers, and so they get that. And even if they're not using Kubernetes now, they can sense that they will be using it in the future.
Yeah, you just stole my question. I was going to ask you. So you were saying, well, one of the reasons is we want to run it on Kubernetes, so it's easy to install it and run it anywhere where they have Kubernetes. And you mentioned Helm, which I love. We had an episode on Helm some time ago. I'm sure you can find it if you search for it. Why are you using Helm? Tell us a little bit more about the experience using it. I'm curious.
Well, I don't know as much about Helm. I am a user of it. I was not the person who created our Helm charts. That was one of our teammates, Richard, who also works on Gopher.js, the Go to JavaScript compiler.
Nice. Oh, cool.
So, yeah, you should direct any questions on that to him. He's the expert on that.
Really cool. So for those that are interested in Helm, we actually had the episode, according to Mark. Thank you, Mark.
That's all right.
Was episode 50 with Michelle Norali and Matthew Butcher. So go check it out if you're curious about Helm. I say that Helm is basically apt-get for Kubernetes. I don't know if that's correct or not, but I like to say it's like
that's
that.
Right. Cool. So
yeah.
It sounds like you're using basically open source, which is awesome for running your applications. What are you using for monitoring? Are you using our stuff or do you use something else?
We use Lightstep, which is based on the open tracing, open source protocol for tracing. And we've instrumented our language servers, our Go servers, and even some of our other infrastructure to just send up traces. And I know that was built by some former Google Cloud people, and it's built on, based on a system that you guys have at Google. So I'd like to think that it's still somewhat in the Google Cloud family, but we love Lightstep.
Cool. At some point you mentioned a little bit about the fact that you were storing some cache. Where are you storing? In general, what kind of storage are you using for Sourcegraph?
We have a couple pods that have Postgres servers in our Kubernetes cluster, and they do not use any special kind of persistence. If those end up dying for whatever reason, then they'll just come right back up and we'll kick off the indexing jobs. We built everything about our infrastructure so that if the data went away, even the global index went away, that we could recreate it in, minutes, even for all of the open source code that matters. So system design was really important. If we hadn't optimized the system to be super fast on the fly for answering any specific question and to do only the minimal amount of computation necessary to answer that question, then I think we would have to think more about persistence. We'd have to, at least have our Kubernetes setup be a lot more complex. It would be a lot more fragile. But because we built our system around not persisting data, it makes our job a lot easier.
Interesting. And I know as well, you said, you've got a Chrome plugin. I know you've also got some IDE integrations. How are you making that connection, monitoring that connection, checking latency? How is that whole pathway from, I'm going to assume GKE, up into the browser and or sort of your IDE integrations as well?
This is like one of those classic CS interview questions. Tell me everything that happens when you type in www.google.com. So, from the user's point of view, they have our Chrome extension and they go to GitHub, they put their mouse over, say, a function call. What happens there is that will issue just a normal HTTP post request to our servers. That is actually a post request. It's like a single shot LSP session using the language server protocol to say, hey, get me this hover for this file in this repo at this character. That will go to our front-end server, and then that will open a WebSocket via this language server proxy that we have to the language server backend. It'll spin up a language server for that repo at that commit, fetch the files. Again, fetching the minimum set of files necessary to answer that question, and then it'll return the data, and you'll just get a single HTTP response on the client, and then you'll show that in a little tooltip.
So now I'm just actually curious, that WebSocket connection, is that internal or is that to the browser?
It depends on the client. Our Chrome extension doesn't open a WebSocket to our server. And if you're on sourcegraph.com or our desktop app, then that will open a WebSocket. No good reason for doing WebSocket versus not, other than we look at average duration of session. And we can optimize it a little bit better if it's just a single HTTP post request. Then we know that we can clean up the resources when that's done. And generally, the average number of hovers that someone does in our Chrome extension is less than the number of hovers they do on a average Sourcegraph.com session. Just some internal stuff like that.
Cool. So still talking about the same topic of how you connect from your clients to your servers. You said that you're using mostly either HTTP requests, like one-off requests, or using WebSockets. I'm curious, are you using HTTP2? Why not like HTTP2 with streaming or maybe even gRPC on top of it?
Well, we do use HTTP2. We have the server do push for some of our assets, and that results in a pretty nice performance increase on the initial load. We use WebSockets for LSP because there were good libraries to do that already. We used to use gRPC for some things like, fetch me a list of the repositories that a user can view. But so much of the client activity was occurring from browser clients. And at the time, gRPC didn't have good support either for issuing requests or for making a RESTful API, which we still needed for other reasons. The gRPC HTTP Gateway project looks super exciting, but by the time that we needed some things out of our API that it didn't support, it wasn't far enough along.
That seems reasonable.
Cool. So we've talked a little bit about monitoring and tracing and all of these things will generate a decent amount of data. So I'm curious about what do you do with that data afterwards?
Well, for things like performance tracing and event logging, we use other services that, like Lightstep, that just collect all the data and we offload that to them. This is for Sourcegraph.com, so this is cloud data. It, is just sent over gRPC protocol, using open tracing to Lightstep, and then we can see, actually, for any operation that occurs on the site, what was the entire trace of every operation that happened. There's actually a debug setting if you are an intrepid Sourcegraph user where you can turn on the ability to get little Lightstep links to any operation you perform. And there have been some times where we've asked users to turn that on, and it's been super useful to collect that.
Do you store it in any intermediary step? Like, do you use Google Cloud Storage, or is it just sent directly off to your third-party services?
Yeah, right now, some of the logs are stored in a bucket on Google Cloud Storage, and then that gets ingested into BigQuery. We have some other intermediate jobs to, associate different machines' log data, apply other transformations to it, normalizations, and then that gets into BigQuery. And then on top of BigQuery, we will run some automated queries on BigQuery to do reporting, and that shows up in our Slack. And we'll also look at the data through a bunch of dashboards that we've created on Looker.
Cool. So does that mean that most of the logging that you do is structured login?
Yeah.
Cool. So you're logging structurally, you send it to BigQuery, and you just keep it there for reports, but do you ever use it as a debug tool, like to figure out what happened to a request, or not that much?
Not that much. Maybe everyone thinks that they're special in this way, but because so much of our system is real time, there's not a lot of persistent data. For most things, we can reproduce the issues by just running things locally because it doesn't depend on state that's stored somewhere else. And we built our system so that, we have a lot of test cases of, here's a really complicated Java project. Can you produce the right hover for this token? And we try to make everything a pure function as much as possible. So, we were actually just talking with someone else who runs ops for a pretty big company elsewhere in San Francisco. And he was asking, how much of your day is spent on ops fire drills and P0s and all that. And I showed him our ops log where we record every P0, and there are not a lot of them. And I think that's because of the way that we built our system and because we built it on a bunch of primitive components that work really well.
Because it's written in Go.
Yeah. Well, there are no bugs in Go.
Of course.
Except when I write it.
So now I'm curious about open source. You mentioned that you're running, so the most of the thing is written in Go, which is open source, runs on Kubernetes, which is open source. You used to use gRPC, not anymore, but your gRPC is also open source. What about other projects? Have you considered things like Prometheus, Istio? What do you think about them?
Yeah, we do use Prometheus.
Oh, nice.
We use Graphite. And we use a lot of open source language servers. We have released a lot of open source language servers for language analysis. And we have a bunch of other open source projects that are on github.com/sourcegraph that various people are using, mostly in Go.
Cool. And all of this is in Sourcegraph on GitHub directly? Yeah. GitHub.com/sourcegraph?
That's it.
Easy. Okay, cool.
Awesome. This all sounds super cool. I'll ask one question as well, because now I'm just interested in Sourcegraph and I've never really played with it. If I want to play with Sourcegraph, like where do I start? Can I just use it on GitHub for free, like on that, or like do I have to pay? Like how do I play with this thing if it actually like if I'm quite keen on it?
Yeah, Sourcegraph is totally free for open source. So just go and sourcegraph.com. You can sign up and then you can just start clicking around on your repositories, or just go to the Chrome Web Store, type in Sourcegraph, get our Chrome extension, and then just start looking at code on GitHub. If you want to look at private code, then you'll obviously have to log in. But for open source code, it's just going to work. Just put your mouse over a token and you'll see the hover.
I cannot recommend that enough. Just adding the Chrome extension makes GitHub so much easier to use. Things like go to definition on a web page, it just blows my mind. So useful.
Yeah, we think that developers deserve things like go to definition, find references, all these things anywhere they're looking at code, whether it's in their browser, their editor, random other web pages. It should be like water. It should be always available.
Cool. I'm going to ask one more question that it might be a complicated question to ask, but we just did an episode on Kubernetes 1.7, and there was a lot of new features. Do you know if there's any of these features that are interesting for you, or are you more like a core usage of Kubernetes, like services and stuff?
I don't know.
That's totally fine.
Awesome. All right. Well, before we wrap up, is there anything that we haven't managed to mention or something you want to plug? Maybe events you'll be at or particularly cool things you've seen from Sourcegraph that you think will be on the podcast before we finish up?
Well, I want to just plug GopherCon, which we went to a few months ago. We had a fantastic time. We had a bunch of Sourcegraphers there, met a lot of our users and customers. We did something that was really fun, and I would encourage everyone listening to participate in the future. We live blogged the conference. So we would just sit in the talk and we'd be typing as the person was talking. And at the end, we'd have a live blog post that we could just click publish on. And then everyone who couldn't make it at the conference could see what was going on and follow along. It was a ton of fun. We got a lot of community volunteers to do it, and we're going to be doing that at a lot more conferences. .go will be one of them, and other conferences in other languages as well. So if you hear of a live blog going on, then shoot us an email if you want to participate by writing or even helping us edit.
Great. So thank you so much for being so active in the Go community and the open source community, but also thank you so much for being here today and telling us a little bit more about Sourcegraph and what you do with Google Cloud.
Thank you. Thank you for making it so I can come and spend some time with you all instead of having to deal with all the ops and systems work. You take care of all that for us.
Thank you.
So a huge thanks to Quinn for joining us on the podcast to talk all about Sourcegraph. Sounds like a super interesting project. I'm a huge IntelliJ user. They've got integrations with everything as we talked about, so I'm kind of keen to get it installed and see what interesting stuff it can find out about my source and give me some nice hints on what I can do with it.
Yeah, for me, really, it is just like the integration on with Chrome that allows me to just browse code on GitHub in a much easier way, to the point that when I use another profile where it is not installed, it just feels like something is missing. So, that's a good thing for an extension. Anyway, it's time to go with our question of the week. And the question of the week is basically, okay, so I have information and I'm storing information, but some of that information should not be stored, right? Let's say that you have a chat, for instance.
Yep.
And normally you expect people to talk to you and tell you things, like, and one of the things that you may ask is like, oh, just to make sure that you're the right person, please give me the last 4 digits of your credit card or your social security number, right? The last 4 digits. And someone by mistake gives the whole thing.
Oops.
What do you do now, right?
Yeah. Or
you cannot just store that.
No, that's bad. Or somebody sends a photo of their license maybe, or...
Yeah. There's a lot of information that is private. Or even more than that, you can have things like IPs or like a lot of information that goes into logs. You just really want to make sure that those things are not actually stored and made persistent. So other people might find them later on, right? Also, it goes against a bunch of rules, actually.
Yeah, there's a bunch of compliance stuff that goes
a
against.
bunch of compliance things that would,
all right, cool.
would stop
So
you.
I don't want to set up a huge number of humans going through all this stuff because that's obviously not going to scale.
So,
What tools do I have available to me?
TensorFlow.
First, we need a model. I think that's the answer to
You
everything.
train the model. Actually, I mean, you could technically do it, right? Like with TensorFlow, you train it so it recognizes what a credit card is, then recognize it so it's like a social security card looks like and stuff like that. And then you will be able to delete those things. And that's what Google has done. And rather than publishing as a TensorFlow model, it is simply an API. So it's kind of like the Vision, Cloud Vision API, where you just send an image and it classifies it. In this case, what you do is you can send either text or images. And in the images, it will find things inside of the image and censor or redact the part that is actually PII, right? Like personally identifiable information. When you're using it, you can say exactly what parts you want to redact. So for instance, you could say, I do not consider faces to be something that I should redact. Or you could say, actually, yes. If there's a picture of anything, make sure that there's no faces on it, right? And these things that, for instance, Google Street View does, right? You do not see faces on Google Street View. You could do the same with this API. It's very simple. The cool thing is that I actually demoed this in Sydney last week on Wednesday. And it was lots of fun. So we'll have a link on the show notes so you can check it out. It's a 5-minute demo, really quick, but it ends up with a pretty good joke, in my opinion. I made it myself, so I don't know.
So you're a little biased?
Yeah, I'm a little bit biased, but I'd say it was a pretty good joke. People laughed, but they were Australian. Maybe they were just nice.
Yeah, maybe not.
No, Australian people are not that nice. No, just kidding.
Wonderful. All right. Well, that sounds like a great way of doing it. If I've got a very simple API that I don't have to learn TensorFlow or do like Fourier transforms or anything
Everything
else
you
like
need
that.
to learn is JSON.
It's just
That's
JSON?
it.
That
Yep.
sounds fantastic. Awesome. Well, Francesc, what are you up to over the next few weeks? Are you up to anything exciting?
More Cloud Summits.
Fun.
Yep. So just came back from Cloud Summit in Sydney. Last week also we had Cloud Summit in Seattle. This week, there's Cloud Summit in Kuala Lumpur and Singapore, and I will not be there. Instead, I'll be here in San Francisco. But next week, there's Cloud Summit Chicago, Wednesday, 27th. So if you're around, let me know. Love to meet more people using Google Cloud Platform, especially Gophers. And after that, in October, I'll be out to London to speak at Velocity. What about you?
Nice. Cool. So when this comes out, that will be the day before Awesome Game Conference, where I will be speaking at 2 different panels, doing one on Kubernetes and game servers, and then also doing a panel with a variety of cloud providers.
Cool.
Talk about games in the cloud. Then I'll be attending Strange Loop, just hanging out there, having some nice recovery time at a very interesting conference.
Jealous.
Yeah, and then in October, I will be going to Australia. I'll be there for Melbourne International Games Week for Unite Melbourne, so Game Connect Asia Pacific, as well as PAX Australia. And I'll also be doing the GDG Dev Fest in Melbourne the day before as well.
Cool. I met a lot of people at Cloud Summit in Sydney that were big fans of the podcast. And
Awesome. Hi.
They all knew your name.
That's good. That's good that some people know my name.
Yeah. So thanks so much for all of the people that I met in Australia. They were super nice and very excited about the podcast. It's nice to see
And meet people.
real people
Yep.
talking to you. It's fine. And thank you, Mark, for taking the time today
Thank you, Francesc, for coming in
to
all the way
help
from the
me.
airport.
to help me go through this hard thing, which is recording an episode jet lagged.
Wonderful. And we'll see you all next week.
See you all next week.